Let's say we have a data frame df. Now this df, if I want to drop rows with any missing values, I can say df dot drop na. And what this does is drop na, it drops rows with any missing values. So if there is like 100 rows and 10 of them don't have any values in particular rows, it will drop those. Another way is to drop columns with missing values. So we can get rid of some of the columns altogether because that might cause some issues, or you don't even need those columns. For example, if you have a data set for property values in California, let's say, and you have some columns over there which talks about weather. Now that doesn't change the value of price because all the houses are in California. And if the weather data is missing, we don't even need that. So we can say drop NA, and in this case, axis equal to 1. So what this does is this will drop columns with missing values. Next that we spoke about is filling missing values. So if we can't drop some, but we need those values. So for example, the same data set that I gave example of California houses. Now it has salaries of people who are living in, or monthly income is available in the data set, but we have 90% of the data and 10% is missing. So if you want to fill that with, let's say, a zero amount, so you can always say df, for example, whatever the column name is. So let's say in this case is salaries. df, I can say column name, I'm just using generic column name, and I can say fill NA of 0. So I can fill a value in there which is 0, which doesn't make sense with salaries, but we'll look at interpolation for that. But you can, if you want to just enter some value, and it doesn't matter if it's 0 or some random number, you can save that here. So it replaces not a numbers or anything that is empty with 0. Next is there's two different types of fills, forward fill and backward fills, that you can do by saying df dot fill na and method equal to, if it's forward fill, you take the forward values, you can say ff f fill. Similarly, if you want to use backward fill, you use b fill. So this will enter values based on the data that is available, forward fill or backward fill, which kind of makes more sense, but still in salaries it makes more sense, but still is not the right way to do it. Then we have interpolation. Now you can use interpolation because it kind of uses a linear interpolation here, where you can get the data set, like for example, California houses and the salaries, but now you can use linear interpolation to kind of add values that are similar to other houses, just because you want to make sure that there is no empty data set, so no empty columns. You can do that by saying, for example, column name equal to df column name, and then you can just say dot interpolate. That's the function that you call. Where did I miss it? Here, interpolate. So this will add values based on interpolation. So that kind of covers our drop missing values. So there's three different methods, as I mentioned. You drop the missing values if you don't care about it. You fill the missing values if you need the values that are available. For example, sometimes there's data available for 95% and not available for 10%. It might fluctuate your values, but depending on what it is, you want to fill some missing values, you can do that. Or you can interpolate. You add based on the data that is available, add interpolation data to the data frame. Next, let's look at data transformation. Now there is three different things that I want to cover here. One is renaming your columns. That sometimes happens where the column is named in a data frame which is not something that you would like or you prefer. So you want to change that. That's renaming columns. You can change the data types. Sometimes you have data sets which are, let's say, a particular column name. You want to change that from strings to float. You can do that here, or integers to float, or float to integers. You can do that. They change the data types here. You can also add, we also can look at an example of how to convert to date time, a particular date that is given in a particular column. And then we have creating or modifying columns. You can modify a particular column. For example, if you have a column with some data, but you want to multiply that with 2, you can do that here. So using data transformation. So I'll give you an example for this. I'll move these down. So let's say you have a data frame, and first you want to rename the columns. So let's say df dot rename, and then inside that you specify the columns that you want to rename. What is its old name? Whatever the old name is, you want to rename that to a new name. You can do that here. So this is how you can rename any of the columns. Next thing that I mentioned about was changing the data types. Now this can be done by saying, let's say if you have a data frame of a particular column name and you want to change the data type from whatever it is, let's say you specify column name and then what type you want. So I want to convert that as type, for example, float. There are sometimes there's data sets that is available in a particular, let's say, integer 64, and you want to convert to integer 32 because PyTorch doesn't work with it, or frameworks that don't work with it. So you can do those transformations using these. You can change the data types like this. df, another one, I'll give you example that I mentioned was converting to date time. So you have data, but that is string, but you want to convert it to date time, and I specify df column name here. So what it does is it takes the existing column and which is string in this case, and it will convert to date time for us. Next, I mentioned about creating or modifying columns. So if you want to modify the data in the column, I can say that, okay, whatever the new column is, or whatever the new column that I want to use the older column, which is, let's say, existing column, and then I want to multiply all those values by 2. Just an example. So create a new column and you modify the value of that column here. So that's how you can create or modify existing columns. Next, let's look at combining and merging data frames. So sometimes you might get data frames from different places, or it might be, let's say, population data for 1990, 1991, 1992. So you have bunch of different data sets available, but you want to combine them together. You can use the concat method, which will concatenate, which will combine data frames along rows or columns. You can do merging, where you can use the merge function, which merges data frames based on a key or condition. And then we also have joining option using join, which joins the data frames using index alignment. So let's look at examples here, how this works. Delete everything here. So if I want to combine 2 different data frames along rows or columns, I can say, let's say for rows first, let's say combine data set, you can say pd dot concat, that is the function. I'll say I want to use data frame 1 and data frame 2. I want to combine these data from axis of 0 for rows. Similarly, if you want to do for columns, all you change is axis equal to 1. So first one will combine the 2 data frames along rows. The second one will combine the data frames along columns. So depending on how you want to use it, you can use these options. Next is about merging, as I mentioned, which merge data frames based on a key or condition. So I can have a merge data set from pd dot, as I said, the function is merge, where you create the first data set, give the first data set, give the second data set, and then on which column, which common column do you want to merge them on? Common column. So let's say you have data about houses and you have data about people, and then you want to merge both those data sets based on the salaries of or income of that particular look of house. So you can do that using this. Next, if I want to do more on now if you're familiar with data sets, this is the first one was merging on a common column. But what if you want to do left join or inner join. So let's look at how would we do a left join. So I can say pd dot merge df1 dataframe2, and then you can say how equal to left and on which column, what is the column that you have, common column in both the data frames, you can specify that. So this will do a left join. If you want to do inner join, you can just say inner here and specify the common column, give both the data sets. So this is almost same as this function, just that how parameter changes. Next, about joining. Now, joining data frames using index alignment, you can do that similar to above. I can say joined equal to df1 dot join, and you pass the df2 here, and you can say how equal to inner, or you can say left, just like before. But this is how you can join data frames using index alignment without the column, just the index alignment. This is what it does. Now that we learned some of these different combinations and how to play with data frames, let's go ahead and work on a hands-on exercise. Our exercise 1 is to clean a data set by handling missing values and renaming columns. The objective here is to practice handling missing data and renaming columns. What we're going to do here is we'll load a data set with missing values, then fill the missing values in numeric column with the mean, and then rename the columns to follow consistent naming convention. So let's go ahead and create day 4 underscore exercise 1.py. Now here first, I am going to import my libraries, which is pandas as pd, and also import numpy as np. So I'm going to use everything that I've learned in the previous days. Then let's create a data set, a sample data set. Since we don't want to use anything that is available, I'm going to create one here, a simple, easy one, where I have names. Names I can enter as a list of, let's say, Alice. We have Bob, and then we have np dot not a number, it's a missing value, and then I have David here. So these are my names. Then I have age column, and this has different values. 25, Alice is 25 years old. I don't know the age of Bob, so I'm going to say np.nan. The third person, I know their age is 30, but I don't know their name, and 35 for David. Now for their scores, let's use, instead of grade, we can use score. This code 85, 90, I don't know how much this person scored, there's no data available, and 88 for the last person. Okay, so I have my data set available. Now I'm going to say df.pd. So this dictionary that I have, I'm going to convert that into a data frame, which we saw how to do it. We just call the data frame function and pass the data to it. So we converted the dictionary into a data frame. Now that I have it, let's print our original data set of how it looks like, /n, comma, it's df is what we're going to print out, the entire thing, because we don't have much data, only three columns and 4 rows. Now next, I'm going to fill in the missing values. Let's run it just to check it out. So I'm going to say Python day 4 underscore exercise 1. So here, there you go, 0, 1, 2, 3, 4. It indexed them, not a number, some missing values here and there. So now let's fill the missing values. I'm going to say df age. For age, I can just say df wherever there is an age, which is missing values, fill not availables with df age dot mean of all the different columns. So based on the mean, just fill this. So it will probably be, I would say, around 30-ish. So let's see what it does. So that's the first part. I'm going to say for score, I'm going to say df score. I will interpolate in this case. It's called the interpolate function. So based on the straight line, it will add some values based on the values that we have here. Now, if I want to print this thing, I can check it out. Let's go here, clear it out, run it. And this is the original data set. Now, if you look at the age, if you see Alice's age, Bob's age is 30, which I mentioned as it will be 30-ish something. Score, if you see it's 89, it's interpolated based on the values that we have here. So even if this person never gave the score, he's not a person, not no name, or scored more than Alice and David, 89. Pretty good, based on interpolation. Next, let's rename some columns. Let's see how we can rename columns. So I am going to say df equal to df dot rename. Now in this case, I want to rename, let's say columns equal to, I will say name. I want to change that to, student underscore name. And then I want to change score to exam score. That's what I'll specify. And then let's print this entire thing. If you saw earlier, it still kept the same names. Now when I do this, clear it out, run it, we have the new student name, exam score is available. Now I can drop this one which has doesn't have a name, but I don't want to right now. I'll keep the way it is, and this is our data set that is available. So this is what I want you to do. If you were able to follow along, good. If not, do so and let me know if you have any problems. Our second exercise is to merge two data sets and perform data transformation. The objective here is to combine the data sets and apply some transformation. What we will be doing is we'll create two data frames with a common column and perform an inner merge based on the common column. And then finally add a calculated column to the merged data set. So let's go ahead and do that. So I am going to create a new file, day4 underscore ex2.py. Okay, let's copy these. These are always required most of the times. And I am going to create my first data set. I will call dataframe1 equal to pd dot dataframe. I'm just directly going to call this instead of creating a dictionary and pass it a dictionary inside it, where I'll say ID is a list of 1, 2, and 3. Next, I'll say name is Alice, Bob, and Charlie. Okay, next one is, let's use age again. And this time I'll say 25, 30, and 35. So I have my first data frame. Now the second one I'll create with the same IDs. So I'm going to say df2 equal to pd dot data frame. And this frame I will give IDs are same. So I'm just going to copy this and paste it here. And then I'll say scores that these students have scored are 85, 90, and 88. So I have these scores available. Next, let's print them and check this out. So I have my first data set /n, df1, right? And I have my second data set. I'll call it data set 1 and data set 2, df1 and df2. So I have my two data sets. Next, I want to merge the data sets. So to merge, I'm going to say merge data set equal to pd dot merge. That's the function that I'll call. Pass the first data set, pass the second data set, and then how do I join it? I said I want to use inner join. And what is the column that I want to join it on? On ID. So I will say ID. Perfect. Next, let's print and see how does it look like. Merge dataset /n comma merged. So that will give me my merged dataset. Now let's add a calculated column to it. So we'll create another column and add to it based on the data that we have. I'm going to say merged. Let's create score percentage. And this percentage will be merged data set wherever the score is, whatever the score is. Okay, I think I have to use this bracket here. Divide by 100 times 100. So this is the percentage. And this I'll say print, and I'll say transformed data set /n comma merged. I kept the name same, so that should not cause a problem. So let's go ahead and run this. I hope you were able to follow along. If not, pause the video, just make sure that you are at this point and then run Python day 4 ex2 actually. So I'm going to go ahead and say ex2. And there you go, our data set initially 1, 2, 3, first data set, Alice, Bob, Charlie, their ages. We have their scores here. Now it's a merged data set 1, 2, 3, Alice, Bob, Charlie, 25, 30, 35, and their scores here. Transform data set, I got the percentage. Now this is out of 100, so of course the values will be almost same unless I change this being out of 200, then it will be 200 and will be half of it, most probably 42, 45, and 44. So that's how this works, and I've created it. So this can be helpful even in like this data set where you have a data set with all the students and you have their scores in a different data set, and then you want to also calculate the percentage, so you can use this entire data set to get what is the overall percentage of students that you have, or how many of them passed, or what is the grade level in there. So you can use this data set for additional calculations. Now that you've completed this, for additional practice, you can drop columns with more than 50% missing values. You can merge 3 data sets and analyze relationship between them. You can also do convert categorical data to numerical using one-hot encoding. If you don't know what that is, look it up, but we'll be covering that in the future. So just to summarize, today we learned how to clean and prepare datasets using Pandas, focusing on handling missing values, renaming columns, and combining data frames. These